Hey everyone, in this video I want to talk about Microsoft Fabric, a fantastic service that provides really a SaaS solution for our organization's core enterprise data needs. Now, if we think about for most organizations the picture today and why Microsoft Fabric is so powerful, often we have data in many different places. I could think about as a company, I've got many different groups. So I've got group 1, there's a group 2, different areas of my organization. Well, each of those, they use different tools. So they have various different engines, an analytics engine, a data warehouse, SQL, Spark, whatever that is. And then they each have their own little areas of data. And today they're doing different transformations because, hey, for this engine, I need it in a different format. But then this group, well, they also want to use a portion of that data. So they have to go and do some kind of export, import, or replication. But now I've got another copy of the data and well, that data can get stale. So basically you end up with all these different silos of data throughout your organization. Some of them are replicas, some of them are conversions because different engines need their own proprietary format. And there's just a whole bunch of work associated with that picture. And then as a company, how do I know where all my data is? How do I avoid problems when, hey, certain copies of the data have got stale? How do I audit? How do I think about data governance, the discovery, the classification, the protection? And yes, it's possible, but it really is very, very painful. And I end up with a massive amount of effort managing all the different data warehouses, the data lakes, and whatever that may be, because there's been this big shift. We used to extract the data from somewhere, transform it, and then load it into some store. But that assumed as a company, I know exactly what I want to do with the data because I've already transformed it into some final format. I've abstracted stuff away. I've removed things. Well, now I can only use it for that purpose. So there was a shift to extract, load, transform, where I would just store it in a data lake in its raw source format, because then I can transform it in lots of different ways in the future. So there was a big shift around that. So I end up with these massive numbers of silos and transformations and copies of the data. And as you would imagine, that is a huge problem. And so this is where Microsoft Fabric comes in. So we have this new solution, Microsoft Fabric. And the goal around Microsoft Fabric is it really provides those complete set of solutions when I think about my enterprise data. Now, it's made up of lots and lots of different workloads. Yes, it has Lakehouse capabilities. Remember, a Lakehouse can have both structured, semi-structured, and unstructured data. Yes, it has a warehouse, that schema-based structured data. It has the Spark engine, so I can do my data engineering, my data science on top of that. There's a data activator, so I can have an alerting system based on certain events. Hey, revenue drops below this threshold, perform this action, send an email telling someone to panic. There's real-time analytics where I can have the streaming of data logs and events. As you would expect, there's Data Factory. We need the pipelines. That's one of the most pro-code ways that I can actually get data in, perform actions on data, maybe move it around. And of course, there's going to be Power BI integration. And something special I'll talk about later on that Power BI gets from being part of Microsoft Fabric. But let's build up the different components and some of the things that makes Fabric different than just, okay, it's a suite. They've took these different solutions and they've bundled it together as Microsoft Fabric, but it's really just the same components. It's not. There's actually a massive amount of innovation and engineering that makes Microsoft Fabric, and I want to deal with that. And the first bit, when you think about what makes Fabric, is we mentioned the idea of the Lakehouse, of the warehouse. So we have to have somewhere to actually store the data. Now, normally one of the problems is we have to get our data into somewhere And you end up with all of those silos. You end up with all these transformations because different engines need different formats that they can read and write to. And that's the really painful part. I end up with lots of different storage accounts based on those different copies of the data. So at the base of Fabric, so I'm going to give myself lots and lots of space. So at the base of Microsoft Fabric is we have the concept of OneLake. So I'm going to give myself a lot of space here. So we're going to think about the idea of the OneLake. And you can think of OneLake as a software as a service version of a data lake. If you think of OneDrive that we have on our machines, what OneDrive does for our personal data, OneLake is going to do for our enterprise data. It becomes that OneDrive for the organization, removing the need for me as a company to end up with some very complex architecture of data lakes and warehouses. It makes it far more intuitive. And this OneLake is very much at the foundation of Microsoft Fabric for your tenant. So what's going to happen here, if you think about you have your Entra ID tenant, so that used to be called Azure Active Directory. So your entire organization, all of your accounts, users, service principals, computers, policies, they live under an Entra ID tenant. So what's going to happen here, if I think that I as an organization have my Entra tenant, it is a one-to-one mapping, i.e., there is only one OneLake per tenant. There's nothing I have to do to get this. It's there for my tenant. Anything I create within Microsoft Fabric, if my account is part of the tenant, will be part of that single OneLake. So I can think about the Entra tenant is the boundary for my OneLake. Any item, which we're going to talk about, that I create within Microsoft Fabric will live within my organization's OneLake. As soon as I start using Fabric, I have my OneLake automatically. There are no silos anymore. There's no button I have to click as the first administrator to create the OneLake. It just exists the first time I try to do anything. Now, that may fill you with a certain amount of panic initially. There's like, well, wait, I need to have some separation between different groups and permissionings. It doesn't mean as a different group, I can set access controls to control who can see the data. I can absolutely still do that. I still have those abilities to restrict, but I'm part of a single namespace. So think about as an organization, my requirement to maybe perform governance and audit. I have that ability now on all of my data, no matter who created it. It's going to be part of this organization's namespace. And it's just all going to happen automatically for me. Now, because it lives within the tenant, there are actually some tenant level settings. If we jump over really quickly. So here I'm just looking at Microsoft Fabric, but you would see up here I have my little gear icon. And one of the things I could do is down the bottom, I have my governance and insights, and I have an admin portal. So I've already opened that up. So this is the admin portal. So these are all the tenant settings that we have available. And there's lots of different things that I can turn on, enable for the organization. I've enabled some of them regarding some of the mirroring settings, but you have a huge amount of control on what I want to enable for my tenant. So I have all of these different governance. There's advanced networking settings I can do down here, some of the audit and usage. But I still have a lot of control within, as a company, what I want to light up within my Microsoft Fabric environment. So think of the OneLake as just that core at the Fabric level namespace. Now I want to actually be able to go and create stuff. Now what I have to do, therefore, is have some capacity. So we have Fabric capacity that then some particular team or project can leverage. And these are typically an Azure resource. So what I would actually do is I would go and create a Fabric capacity within my project's Azure subscription. So if I'm going to I want to control the billing, I want maybe some area of compute capacity that I want to be able to leverage within my group, I can create my own capacity set. So if I jump back over here, and if I actually this time look in the Azure portal, we can see we have this concept of Microsoft Fabric. And what I'm creating here is a Fabric capacity. Now, my Fabric capacity, you can see scale. It's of a certain size. So you can see I have all these different sizes available to me, all these different capacity units. You also create this in a specific region. So that's going to control where the compute is, but it's also going to control where the data that is created is associated from a regional perspective. And I can create as many different Fabric capacities as I want. There's even trials. So I could actually go and sign up for a trial. I get these 2 months. I think I get a pretty big SKU if I remember correctly. I actually think I get the F64 SKU for 2 months. So it's a massive amount of compute I can go and play with. But I can therefore go and create one of those capacities. And here's the pricing page that goes through, again, the details of all those different capacities. So I pick a certain SKU, and it's the amount of capacity I can use per second. And obviously, there's also aspects when I actually go and store data. There's storage prices as well based on the gigabytes I'm storing per month. And I can also do BCDR. So by default, it's zone redundant, the storage, but I can do geo redundant as well. Now, the thing that's really important to understand about this is, so if I think what I'm doing now is we had our OneLake. I then, within my organization, I create these different capacities. So moving up a layer from there, I would then go and create as many as I want, but maybe a different certain business unit. I would go and create my capacity 1. A different business, hey, they go and create their capacity 2. And remember that capacity is of a certain SKU. So that maps to that amount of compute scale that it can perform. Now, one of the things you may have noticed on that screen is I can actually pause and resume this. So it's billing me at a per second level, I think with a minimum of a minute. But again, if we jump back and I go and look at that, notice one of the things I can do is I could pause it. Now mine is currently active because I actually need to perform actions on the items that live within the associated things for this capacity. But if I know I've got quiet times, I can absolutely go and pause. I could write automations. So I could have some logic app or Azure function that at certain times could go and pause and resume that capacity. So yes, there's a cost associated with it, but I could pause it. I can change that size very easily up and down as maybe my needs change throughout the day, week, month, whatever that may be. And it's a virtual amount of capacity. This is not going and creating a VM, for example, or a container with that many vCores that equates in some ways to that capacity. It's a virtual bucket of capacity my workloads can use. Actual physical capacity is not assigned until I try and run some job. So it's all serverless. What I'm buying is a virtual bucket of capacity I can use. And then all of the different workloads that I can run in Fabric go and use against that amount of capacity in that bucket. So the jobs, when they execute, actually go and get assigned physical capacity, which equates to a certain amount of that currency, that virtual currency that gets billed against that bucket. So behind the scenes, I might get infrastructure spinning up for SQL, a separate infrastructure spun up for Spark, a separate infrastructure spun up for analysis services and Power BI. They all then just tell that central capacity tracking, hey, this is the amount we're using. It maps that to that virtual amount. And as long as I'm staying within that level, hey, everything is great. So I can go and use it for many different types of workload. But it's better even than that. If I consider over time, let's take a 24-hour period, just for example. And let's say what I've purchased is that amount. That's my SKU. That's the number of those fabric capacity units I have available to me. And then there's the actual amount of work I'm doing. So maybe I'm hovering over here, but then I have some peak amount of work. So then it shoots up. It wants to use way more than I've actually paid for. I can burst. And then it does something called smooth. So it lets you go above the amount of provisioned virtual capacity you have. So I can burst and use a lot more for an amount of time. And then you kind of owe it. You owe it some capacity. So it then will smooth it in your quieter times. Now, the amount I can burst varies. For my long-running background, my scheduled jobs, it'll actually let me smooth over 24 hours. So I could run something way more than what I've actually provisioned and then pay it back. If it's a shorter, more interactive, it's smoothed over a variable amount of time based on what it needs. And the amount I can burst is actually huge. So if I look at the documentation, based on the SKU, for the really small one, now I'm running the cheapest, smallest one because I'm cheap, I can actually burst to 32 times. Now realize, if I'm doing small experimentation, the F2 is probably fine. And most of the things I'm running maybe run for 10 seconds. But for that 10 seconds, I could use 32 times that actual amount of capacity. So I could actually use the same as what a 64 is capable of doing. And then it will just need to pay it back over the next 5-6 minutes, whatever that time is, whatever I've bursted beyond. Now, the bigger you get, the scaling factor starts to reduce, but even for the biggest ones, it's still 12x. So if I have those scheduled jobs, those long-running jobs for maybe a couple of hours, hey, I could run for maybe 1 hour with 12 times the amount of actual capacity, and then I just pay it back over that next 24-hour period while other things are still going on. Now, if I start to go beyond those limits, it will start to throttle me. And eventually, if I keep pushing it, it will start rejecting the jobs. So there are finite numbers. So I may need to go and change that scale for that various capacity. But it's super flexible. It's really trying to help you optimize the spend, but be able to do some pretty fantastic things well above that if you actually need to. Okay, so where we are right now is, okay, we have this tenant level OneLake, that everything to do with Fabric within our tenant will be part of that namespace. So it's easy to find, apply governance controls. Then I need to create capacities. It's all serverless for the actual workloads, but obviously I still have to pay. So I provision a virtual bucket of capacity, then all the different workloads that get associated with that capacity, draw from it, and I have these great, nice burst capabilities. But how do I then actually create the workloads? Now, as a team, as a project, I'm going to have many different types of item. Maybe it's a lakehouse, a warehouse, some notebooks, maybe it's pipelines coming in, semantic models for my Power BI. And I want to be able to organize those and maybe set permissions on those. So our next layer is we go and create workspaces. And I associate my workspace with a capacity. So again, under here, maybe I have my workspace 1. I can have another workspace under this capacity. I have a workspace under this capacity. You get the idea. So I associate a workspace with a specific capacity. In many ways, think of it like in an Azure world, I create a resource group to group like things together, and I can apply certain policies on a resource group and permissions on the resource group. It's really what Workspace is doing for me here within my Microsoft Fabric. And once again, let's go and have a look at that. So let's just close those down. So this is Microsoft Fabric. This is kind of the main introductory screen. If I just jump to app.fabric.microsoft.com, it's showing me those key types of workload that I would have as part of this, which we're going to talk about in more detail. I have my little menu down here in the bottom corner that lets me jump to different tools, but also different experiences. So my data engineering, data science, a data warehouse, whatever that may be. If I just jump over to my data warehouse, for example, one of the things I can see here are all my different workspaces. Now, if I select that, we can see here I've created one already, which is what we're going to be using for most of this little demo. But I can also create a new workspace. And the key thing to bear in mind here is I give it a name. And the important part is I have to assign it to a capacity. So here, for example, now notice there is a trial option. I don't have the trial active in my tenant. I would see a trial option, for example. But I'm going to do a fabric capacity. And here you pick the capacities that you have available, that you have permissions to. So hey, I want to create a new workspace. I'm using fabric capacity. What is the semantic model format I want to use? And then the specific capacity. So multiple workspaces can use the same set of capacities. So it's not a one-to-one, and it's really just that organizational construct. And then if I jump over here, this is that sample workspace. I've got it open. Even within the workspace itself, I can see I have workspace settings. There's different things I can do. So for example, my Spark settings, I have various controls. I'm going to come back and look at this in more detail. There's some network security, potentially depending on the SKU you're leveraging. I can see some of the details. I can update the little icon for it. There's things I can do here. I can manage access. So this is where within that workspace, I could grant different people, groups, permissions to this. But these really are just organizational structures. If I just go and start browsing, for example, I can see that basic workspace over here. If I look at my OneLake data hub, I can go and select a certain workspace, and then looking down here, I can go and see all the resources under that particular workspace. So it's really just organizing my things. And I'll give you a sneak peek at something. There's even a desktop application that I can use for OneLake. And when I look at this, it organizes the folder structure by my workspaces. Now I would see any workspace I have permissions to. I only have one. And then if I open that up, then I see the items I have within my workspace. So it really is just an organizational structure. And that's the key goal around this. So it gives me a lot of different flexibility. So I create these workspaces, and then based on the workspace, I'm going to want to do certain things. Now, again, within it, I might see lakehouses, warehouses. I'll see all these different things, but they're just items that get organized within a particular workspace. That's the goal for this. Okay, great. We're nearly ready to actually start creating some stuff, which is the goal of what we want to do. So we talked already about the fact that this is at a tenant level, we have this OneLake. And before, we talked about the idea that we have all these different engines that are used by many different types of workload. And we already saw they all still exist as part of Fabric. In that main page, we saw the different tools, we saw the different experiences. So under Fabric, I still have all of those same things. So I can think from an engine perspective. So from an engine perspective, I still have, I'm trying to line this up, Spark. And of course, my Spark could get used by kind of Data Factory. my notebooks. I have my T-SQL. So that's going to be used for a data warehouse. I have KQL. I may have a KQL sort of query set. I have analysis services. Obviously, the huge one there is going to be Power BI. So I have all these different tools that talk to different engines. And we talked before about the challenge we had was they each used their own specific format. They used to work with a certain type of data. So if I had some data in a data warehouse, and then I wanted to be able to maybe run some Spark via notebooks analysis on it, I'd have to start replicating and messing around with the data, which was painful. That's a very negative thing. I never really want to have copies of data. It's hard to manage, to govern, there's staleness issues. So that was always a huge pain point. So what's happening here? When I look at everything we're going to create under OneLake with regards to storage of any kind of data we want to use with those engines, if I think of the data layer, so let's think about our data. What's going to happen here is under the covers, it's still using ADLSGen2 accounts. It's still creating instances of those data lake storage accounts that can really store anything and at those massive scale, but it's completely abstracted away from you. You don't need to worry about that. It's going to create them as it needs to. So it's going to take care of the underlying physical storage. And then what's actually going to happen is within this, everything it writes, well, it's going to store it as Parquet files. And specifically, it's storing it as Delta Parquet files. So think of Parquet as the actual storage of the data. Then what you have on top of that is we have the metadata. And what it's doing here is it's using that Delta log format. So on top of the Parquet, it's using Delta log. So we have Delta Parquet storage is going to be used for everything. And what this means, and what has happened here, is this is a huge amount of the engineering effort that went into Microsoft Fabric. Yes, they created the OneLake, this new namespace. They then invested in this open standard, the Delta Parquet format, that everything is going to store from these engines. So what that means is now they updated all of these, the Spark, the T-SQL, KQL analysis, they speak Delta Parquet format. So if I have these Delta Parquet files, and that's how everything gets stored now within that OneLake, all of my structured data is as Delta Parquet, it doesn't matter who wrote the data, everyone can now read it. So from this Delta Parquet format, T-SQL can read it, KQL can read it, analysis services can read it, Spark can read it. So I could have the scenario, data warehouse, job, wrote some data, I can read it from Spark. Spark wrote some data, I can read it from analysis services, I can read it from T-SQL. I can lay Power BI over everything. So they've removed those silos and those proprietary formats that I had before that led to this ugly replication and transformations and copying that I had. Everything has been updated. The engineering went in to make everything write to Delta Parquet format, and everything can read Delta Parquet format. So there's no more proprietary format that inhibits the ability for different engines and therefore tools on top of those to work with any of the data within our organization that's within our OneLake. They made all of that work to speak Delta Parquet. So it's one format, non-proprietary, for all of the different tools. I don't have to worry about staleness or copies. I have that complete flexibility. And Parquet is that column-based, columnar, very good compression for that column-based data. So that's the data storage. And we can see this. So if I jump back over to my view here for a second, and if I was to look at my Lakehouse for a second, and I look at my tables, which is the structured area of my Lakehouse, and I look at one of my sets of data, my dimension customer, we see it. We have the underlying Parquet files that have the actual data, and then I can see the delta log, which is that metadata. So that's how it's storing it under the covers. And the fact that we have this delta-based storage actually does some really interesting things. So the Parquet, great. Efficient compression, good for actually storing the stuff. And then metadata. So the metadata, the properties of the data, the changes to the data, it helps provide that ACID compliance that's so important to many of the types of operations we ever perform. We need that atomicity, the consistency, the isolation, the durability of the transactions within now that open format. And that delta log has information about the table itself, but also the history of all of the transactions and the changes to the table. So what this means is with this, I can time travel. I could actually go back and look at a different period in time of the data without having to store it again. I can just use the delta log with the Parquet to say, hey, what did the data look like 2 days ago? I don't have to change any of the actual data. I can just go and do that. And I'll say this again, but if you take one thing away, this is massive in terms of what Microsoft Fabric brings to the table. Yes, it's this fantastic namespace that's organizational wired to make it easy to discover, govern, audit. But the fact that they've made the engineering effort that everything now writes and reads from this open Delta Parquet format, it removes all of those barriers we had before for the different engines. And suddenly all my different data I have in my organization, I can leverage from all the different types of tools based on the types of activity I actually need to do. There is something else as well they did. So there's something called the Vertipack engine, which can do V-ordering. So V-ordering is a write time optimization for that Parquet file format, and they do this. And so what that means is when you do this V-ordering, it gives you amazing performance when you're performing reads under these different engines. So if I'm using Power BI, SQL, Spark, they leverage that Vertiscan technology and that V-ordering that gives you like an in-memory access time. So not only is it using this open Delta Parquet format, they're using the Vertipack engine, that V-ordering for all of the writes, which means the performance is going to be phenomenal when I start actually doing things against it from my data warehouse, from my analysis services. That's a really, really big deal. So I should probably call that out. So yes, it's this, but it's also this V-ordering. Give it a smiley face. So for super fast performance in our files. Okay. So now we're actually starting to get to some of the really interesting things about what makes this Microsoft Fabric and the OneLake so special. Now, it does actually go a step further. So if you think about the delta log is the metadata that's providing information on top of the actual storage, which is Parquet. What that means is technically I could support other metadata formats to make it even easier for other things to work with the data in the OneLake. And the one they've started with and introducing is support for Iceburg. So additionally, they have Iceburg metadata support. It's just another metadata format. And where Iceburg is very much used is Snowflake. Snowflake speaks Iceburg. So what this now means is Snowflake can natively use OneLake for the storage of its data. And what that also then means is I can now leverage the data that Snowflake has written from all of the other workloads, and other data I have can be leveraged by Snowflake. Because what's happening is Microsoft have used a technology to do conversions between them. So if we think about, there's this X table. So we have two different metadata formats. And it's using X table to do those conversions. So that's an Apache project, Apache X table, but it does a translation between the metadata formats, between the Delta log and that Iceburg, which now gives me complete flexibility that, hey, Snowflake is another workload that can go and interact with the OneLake, and it's not a silo. And that's the key point. I don't want to introduce silos. I don't want, hey, Snowflake could write to it, but nothing else could read it. Sure, Snowflake speaks Iceburg, but then the X table that's been implemented does translations between the different metadata formats. These all support Delta log. Well, it's going to do conversions. Hey, other stuff, Snowflake wants Iceburg. It can take the other data that these have written and make it available to Snowflake. So now I get this really good compatibility between all my different workloads. I have a massive amount of data now, as we're going to see as we go on, in my OneLake, in this Delta Parquet format. And we saw under the covers, remember, we're using ADLSGen2 accounts. Well, ADLSGen2 has the ADLSGen2 API. That's a very well understood API that we use today to speak to ADLSGen2 accounts. Well, what the OneLake does is we get this OneLake namespace. So now all I have to do is if I speak ADLSGen2 API, which is a very widely adopted API, I just change the target I'm talking to, and suddenly now I can communicate with the data. I would see the Parquet files. I would see the Delta log. I would see the unstructured data that maybe I'm storing in a Lakehouse I'm going to create in there. But it makes it super flexible and available. So now any app can just go and speak the ADLSGen2 API and can talk to the data in the OneLake. Your existing tools, so if I was using Azure Storage Explorer, well, that talks that. That will just work. Databricks. HDI. They speak that as well. It becomes this data platform that is not just for Microsoft Fabric. Azure AI Studio. All of these things can talk to the ADLSGen2 REST API and the SDKs. It's not some special OneLake API. So it makes it very easily for workloads to now integrate. So anything can use those open integrations to now use the OneLake. That's the whole point. It's not just for the engines that are part of Microsoft Fabric. Nearly everything speaks that API. It's an open integration that other vendors can go and add new capabilities for just using that. And that's really huge. And again, we have those additional metadata now for things like Snowflake can hook in and talk as well. Now, additionally, what this hopefully is making very clear now is I don't have multiple copies of my data. I have a single point of truth. Every workload can read the data that has been written. There is no separate sets of transformation or imports based on the engine or the workload I want. They're all speaking that Delta Parquet format. There is no separate, hey, I've got one analysis over here, one need a different type of engine over here. Let's do some ETL or transformations or Spark or Databricks. None of that happens. One question that does come up. Okay, so I have this OneLake namespace. I'm using the ADLSGen2 API. So I'm talking network traffic. What are the abilities to restrict that today? For example, private link is a big one. Private link creates an IP address in your virtual network that represents access to a single resource. Today, all I have is at a tenant level. So at a tenant level, if I look at my tenant settings, I think there's advanced networking somewhere. You see there's a lot of different settings here. So advanced networking. I can turn on private link, and then I could block public internet access. But that's at the tenant. So that will impact every single workload. That's pretty broad. And you'd have a lot of considerations before you just went and turned that on. They are working for workspace level. I think that is on their roadmap to have that. Now, at a workspace level, if I can find my workspace, this tab, I'll just go to it. So at a workspace level, if I look at my workspace settings, let me just go back. There you go, sample workspace. At the workspace settings, you do see network security. However, this is managed private endpoints. And what this is about today is for my workloads running inside Microsoft Fabric to go and talk to other resources I have in Azure. So that's more the other way round. That would be, hey, I've got some Spark job running in this workspace. It wants to go and talk to an ADLSGen2 storage account that has a private endpoint. So it's letting me connect to something to be able to do processing on it. It is not a separate private endpoint to utilize the services of the Fabric. That is not there today. Again, I think it's on the roadmap. So today, at a tenant level, I could turn on private link. I could block public access. But you'd have to really be careful about all the ways you're using the Microsoft Fabric services to ensure that didn't go and break something pretty significant. Let's talk about items. I've mentioned items, and I've said the word Lakehouse and warehouse and notebooks a few times. Let's actually dive in to see what those things are. Because remember, what we've created at this point is we created a workspace. The workspace was associated with a capacity, which gives us that serverless compute for the things that I actually want to do. The workspace lives in a region that will govern where data we create is actually stored. But now I want to actually be able to store things. Well, I need an item into which I can store things. And very often, the first thing we're ever going to create is a lakehouse. Now, that's not a rule. That's not to say that has to be the first thing you create. But very commonly, we're going to go and create a lakehouse. Now, when I think of a lakehouse, lakehouse 1. The whole point of a lakehouse is it's a container for some type of artifact. And it supports both structured and unstructured. So the unstructured, what we'll actually see off of this is we'll see a files node. And then I can create folders. I can see a structure and items under that. For the structured, I would see a tables node. And obviously everything in the tables, well, it's actually not strictly true, but most of what we do in tables, obviously we're going to store in that Delta Parquet format. So the Lakehouse is that first item that gives us the unstructured and structured. Now, as I start to create things, remember I showed you this already, that OneLake namespace provides access to all of these things. And I'll see everything I, as the person looking at that, have access to. And remember, it will be broken down by the workspace and then the different items under it. So I'll see a Lakehouse 1, maybe I'll see a data warehouse 1, maybe there's a warehouse 2, and then maybe I've got access to workspace 2, and under there I see another Lakehouse, etc., etc. That's going to be the namespace that we see. So all of the things I start to create, I will see under that namespace. So if we go back and look again, I'm looking at a particular workspace, and I can see the different items I have here. Lakehouse, you can see I've got a Lakehouse, I've got a warehouse. And remember, when I looked at the file system, what I actually saw is I only have access to the one workspace, so that's the first structure. Then when I go into that, I then see the things that have storage. I'm not seeing my notebooks, but hey, I can see my Lakehouse, I can see my data warehouse. If I look in my Lakehouse, I see tables, which is the structured, and then files, which is anything. So files, well, I put in some pictures, I put in a CSV file, which is what I use to import in to populate some structured in my Lakehouse. I have some other data I use to create my warehouse. And remember, again, if we actually go and look at the tables, which is the structured, all I'll see in here are the Parquet files, and then we have those Delta log transactions, which are up there. So my Lakehouse is very commonly going to be the first thing we create, because I can have that collection of both unstructured and structured. And then on the Lakehouse, I can run various different workloads. I can run Spark. Very commonly, I'm going to run Spark. I'm going to run notebooks on it to go and actually do population, maybe a data factory to go and populate those things. And I'm going to see everything I have access to. And if I was to look within here, so here I'm in my workspace. If I just go and select my Lakehouse, I'll see that same structure. So I can see here I have my various tables and I have my unstructured data. Now, just pay attention to the icons for a second. So if I select my dimension customer, so this is obviously structured data. If I look at the icon, the little triangle tells me it's stored in Delta Parquet. Technically, Spark could write non-Delta Parquet. It would still show in tables, but it won't have the little Delta Parquet icon. So I can still run Spark, and I could force a different format. I could force to write to CSV. I could force to do something else. Typically, we're not going to do that, but I could. Notice on this one, it's also got a little link. So that's a shortcut, and we're going to talk a lot more about that. But here I can go and see all of my Delta, Parquet-based data. I can do various things about it. The other really cool thing, and this again speaks to compatibility, is, and actually just show you the files so I can see all the files there as well. But when I look at this, at the top, I have this drop down. It also gives me a SQL Analytics endpoint. So now I could switch over to this. Now, it's only going to show me tables, obviously. SQL can't go and look at the unstructured, but I see exactly the same data. I could now go and access that data without having to understand or use Spark. I could just use T-SQL. Now, this is a read-only mode. It's a read-only mode over the Lakehouse Delta tables. I could say functions, views, I could have SQL object level security, but I can't write to it. This is just the ability that I could run analysis over the data in that structured tables part of my Lakehouse. And again, I could go and switch back, and it's the same data. It's just giving me that flexible capability to leverage those things. So great. I now have the ability to start storing stuff. But realize, for many organizations, I have data in other places. And I said that word shortcut, and I showed that little icon. Now, the shortcut is a feature of the Lakehouse. And the whole point is I have data somewhere else that I want to bring into visibility of the workloads that talk to OneLake without having to actually move the data. So I could think about, hey, maybe I have data in AWS or Google Cloud or other ADLSGen2 storage accounts. And I want to have the look and feel like it's in OneLake without actually doing that migration. It's a symbolic link. So the key point here is I have data somewhere else. So again, it could be AWS, GCP, it could be in Azure, another location in Azure. And what I'm going to do is I'm going to create a shortcut. Now, I can create a shortcut to anything into files, or if it's Delta Parquet format, I can create it into tables. So this has to be Delta Parquet. So if the thing I'm trying from here is in Delta Parquet format, I can do a shortcut into tables. If it's not, then I can do a shortcut into files. And then once it's in files, maybe then I do something else. I could maybe do some translation, do some conversion to then make it available in tables. But I can shortcut from there into it. I could also, hey, maybe I have data in other places within my OneLake, another workspace that I want to be able to leverage within here. Well, I can shortcut in there as well, which is exactly what you saw in my environment. So when we looked at my environment, if we remember those icons for a second, notice this one has a shortcut. Holidays is actually, let's go back to my sample workspace, stored in a completely separate item. It's stored in my data warehouse. So that was brought in using SQL. But I want to be able to use that data in a single way and interact with it via my Spark, for example, within my Lakehouse. And so what I added, let's go back to my regular endpoint. In tables, I just did new shortcut and I added it in from within there. Now notice what I can do. It's telling me, hey, look, I can do stuff from internal sources, which is what I did right there. But it also lets me do from Amazon S3, Google Cloud, other storage accounts, Dataverse. So I can bring in shortcuts from all of those places. And what this is letting me do is it's not moving anything. I don't want to do an upfront migration of the data, but I want to play with it. I want to experiment with it in Fabric. So I can shortcut it into Fabric, use it with any of the engines. It's all being accessed via this symbolic link. And again, remember, I can put anything into the file section, but it has to be Delta Parquet to shortcut into the table section. There is actually a caching option I can do. So obviously, it's still, every time I'm interacting, it's reading from these, so it may have some cost implications to there. So within the workplace settings, I can turn on a cache, which could help with those egress capabilities. What about if the data is not available in Delta Parquet? What about if the data is in some proprietary format? What if I'm working with Cosmos DB or Azure SQL Database? Or, different from that, Snowflake. What if I want to be able to work with those proprietary storage formats within my OneLake? Well, what I can do here is I can introduce the concept of a mirror. Now, this is a separate item. This is created as a new item. A Lakehouse is an item. A warehouse is an item. A notebook is an item. A mirror is an item. So it's something created within my workspace. And what this is going to do is it's using change data capture so that as things are changed, it writes it into the mirror and it does a transformation. So now those will just appear as part of my OneLake. And what that mirror is doing is it's doing that transformation and it goes and writes it into that Delta log format. So it can then be read and processed by all of those other engines. And we'll see those three types. So if I jump back over, now I had to enable this in the tenant. At the time of recording, this is not there by default. And again, this is actually a mirror. It's taking that copy of the data. So I can then consume it from within the workloads in my engine. So if I go and look at my workspace, and let's do a new, I'm just going to say more options. So this is everything I can do. So if we look at all the different types of things I have, if I look at my data warehousing capabilities, I can see mirrored Azure SQL Database, mirrored Snowflake, and mirrored Azure Cosmos DB. So easily replicate data from existing source into an analytics-friendly format. The really cool thing here is, chances are I'm not even going to have to pay for this. So if I look at the pricing for a second again, I don't have to pay for the work to transform. And I get free mirroring storage for the replicas up to a certain amount based on my capacity SKU. So if I was running an F64, I get 64 terabytes of storage for free. So the transformation is free. The storage is free up to these amounts. Then I'd obviously have to start paying for it. But it's a really nice way to go and get access to consume from all of the engines within my OneLake if it is stored in some proprietary format. And it's only if I go above those numbers, then I would start paying for that storage. Now, obviously, I pay for when I start reading and consuming it. I'm going to use up my capacity for the consumption, for the reading of the data. But the actual maintaining of the mirror, the work to do the transform, the writing of it, and the storage depending on my SKU of the underlying workspace and that capacity the workspace uses may not cost me anything. So it's just another option to what I can do. But again, this is a one-way replication. This is making it a read-only set of data that I can then consume for analysis within my OneLake. There's another thing I can do, I guess within here. Imagine I talked about within my tenant. Imagine there's someone else. So imagine for a second there's some external person over here, and they have their OneLake because they're in their tenant. And what I want to be able to do is I want them to be able to have access to tables or files residing in my Lakehouse or a KQL database. I could do the same thing. I don't want them to copy the data. Think of like a shortcut, but going the other way and something external to my Lakehouse. Well, I can do that. One of the things I could do is from my Lakehouse, I can do an external data share. And what this lets me do is from within my particular Lakehouse, I can say, hey, I want to go and share this piece of data. And it probably doesn't show up on the board very well. It's a poor color to pick. I give the target of the person that I want to share the data with. Then I select the items I want to share. They are not getting a copy of it. It is not a duplicate. It's a reference to the data in my OneLake. I have to enable this at the tenant level, but now I can go and send them an invitation. So if I jump back over again, And I'm in my warehouse. I'm looking at my Lakehouse. Notice I have this option, external data share, because I've turned this on within my tenant. All I would now do is I would select the particular things that I want to share, specify the person that I wish to share it to. They would then get an invitation, and then once they accept that invitation, they would now be able to pick where they want to shortcut that in their OneLake hierarchy and be able to consume and work with that data. And again, I could rescind that at any time if I wanted to stop them being access the data. Okay. I said the word warehouse. I said I did a shortcut from a warehouse. So obviously we also have the concept of a warehouse. Running out of colors here. So I can create warehouses. This is an item. And the big thing here with the warehouse is, yes, we very commonly start with a lakehouse, structured and unstructured, semi-structured data. And then as I start to get focused and I start to refine my data, I get down to that structured data, I then maybe want to put it into a warehouse. I want to do more maybe interactions with SQL to go and write into that data. Now with a PaaS offering, remember, I would be putting all the compute, the storage, the resource groups and networking. I put all of that in together. This is a SaaS. It's very easy to use. I just create this as an item and it's ready to go. And it's decoupling the compute and the storage. So it's the serverless compute. When I run the things, it's going to go and consume from that capacity that sits under the workspace under which I create my warehouse item, and then the storage. And once again, the storage, remember, it's in that Delta Parquet format. As we talked about, I could shortcut things from here into the tables. I can do all of these wonderful things. And what's crazy about this is I think it's the first warehouse that is using this open format that have papers with 1 petabyte scale. So they've done massive tests. And remember, again, because of that V-ordering, they get phenomenal performance from that. So I've created a warehouse item. We saw that already within my environment. So within my workspace, and we can see I've got a warehouse. And we can get data in many different ways. There's pro code, low code, no code ways I can get the data in, but it's all structured. The whole point here is it's schema based. I've got the structure, I've got my data. If I run a query, remember what it's going to do is just like everything else with SQL, there's a query estimator that estimates how I can run that query very efficiently. So there's a unified query optimizer as part of the warehouse solution. And every query I run is actually broken down into tasks. Those tasks are executed on virtual core, some of them in parallel, which enables a much faster execution compared to the older step-based execution we had with our data warehouse. And those assigned vCores obviously map to a certain amount of Fabric capacity. And once again, it uses that burst and smooth, so we don't have to suffer if we're running something fairly big and we have a certain base amount of capacity available to us. And it does compute isolation. And what that means is, imagine I'm doing an ETL job. Well, that's not going to interfere with running queries. So query and ingestion of 2 very separate non-competing compute pools. So it's going to help avoid that noisy neighbor problem. So it is the first transactional data warehouse using that open standard format with the ACID compliance. It's auto integrated, it's auto optimized. You don't worry about really anything. You're not worrying about hash distributions or workload groups that we would normally have to worry about for optimal performance. It's doing all of that for you. Think of this as that SaaS offering. Because of that V-ordering, it gives a huge performance boost for the warehouse and Power BI when I was leveraging that as well. I mean, we're used to the idea of a warehouse. From a features perspective, there's something for everybody in terms of the extract, transform, load. And it's really designed that based on your skill set, you can get data in different ways. For pro code, yes, data factory. And we see that when we go and look, for example, so I'm in my data warehouse kind of view over here. If I was to do create, and we look at our data warehousing, yep, I can go and create a new warehouse over here. When also, let's go back over for a second. I can get data. I can do a data flow. So a data flow is just very much low code. It's like a visual Excel-like experience. I can easily do transformations. Remember, we saw already the idea of shortcuts and mirroring with a no code. Pro code, sure, I can use data factory. So I could go and use full data pipelines. I could do stored procedures, but I need the skills to do that. I could just run SQL commands. I could use CTAS, create table as select. So I have a vast number of experience on how to get data actually into my environment. I can do cross database queries, native, shortcut, mirroring, it doesn't matter. And this is something you're going to see time and time again. The whole point of all of this is whether the data is natively stored, whether it's been shortcut, whether I'm doing a mirror, it doesn't matter. It all appears the same to all of these engines that want to go and consume it. I can build a virtual data warehouse over all of those different sources. I can even save the view. So I can create these new views and then query based on that. There's a visual query capability. So if I jump back over again, I can do a new visual query. And I can just start dragging the tables over. And then from here, it will show me the data that's currently there based on what I have. But you notice there's functions to reduce rows. I can manage columns. I can do sorting. I can do transformation. I can combine things. I could save it as a view. I could view the SQL that's powering it. It's giving me that preview down here. So it really gives me a nice experience to start interacting with the data within my data warehouse. And something I'm not going to mention in any detail right now, but Power BI gets some really nice benefit from the OneLake in how it can talk to the data here. We used to kind of the idea that, well, we can import, we can do a translation, but the performance suffers, I get lag. There's something very powerful now that because of this Delta Parquet format and the work done in analysis services, we get a direct mode. We get a direct lake mode that doesn't have to import the data, but doesn't have to do translations in how it can talk. So you can get this phenomenal Power BI performance as well. It's doing automated table maintenance. It's optimizing the compaction, the checkpointing, because normally Delta and Parquet, each operation I perform would be a separate Parquet file. So if I was doing singleton operations, I'll end up with a stack of Parquet files, which is why we normally do batches. But any update, well, it's a delete and an insert. This is going to go and tidy that up automatically for me. So instead of having to worry about fragmentation right in some job and I have to go and optimize and compress myself, the storage optimization will look at the Parquet files I have and what can it do across them to get me to a smaller number of larger Parquet files that will give me increased efficiency. So there's a whole set of work being done to just increase that warehouse experience. Now, I know one of the questions that I had when I started to look at this was we have a Lakehouse, which has a structured bit, and we have a warehouse, which is structured only. And the Lakehouse, remember, has a SQL endpoint, so I can consume. Do I use a Lakehouse or do I use a warehouse? The whole point, because I can put that SQL endpoint on the Lakehouse, the front end experience, it can be the same. Creating views can be the same. Reading the data. The difference is what engine do I want to use to write the data. I base the decision on how I want to do the authoring. The consumption doesn't matter. I cannot use the Spark engine to write into a warehouse. I cannot use the T-Seq engine to write into a Lakehouse. So do I want to write stored procedures or do I want to write Python? How are you preparing the data in the first place? So it's really that tool. What tool as a developer am I using? If I'm using relational databases, if I'm using SQL, if I'm using a warehouse architecture, if I want multi-table transactions, well, I only get that in the warehouse. That's a very pure warehousing capability. Locking multiple tables, I'm going to use the warehouse. If I'm more code first, if I'm writing Python code, if I work in notebooks, if I'm using Spark, I'm used to working with messy data and getting in shape, I use a Lakehouse. But often it's not an either or. Most of our solutions, I'll have instances of both. You may have heard of the medallion architecture. And what's really cool is Workspaces will help you with this. If we jump back for a second, so I skipped this a little bit, but if I go back to my workspace, we could see all of the resources within my workspace, sure. But if I drag this little bar here, it opens up this task flow. And what I can do here is I can select a task flow. So these are common task flows I might use, and one of them is medallion. So if I select this, and it's telling me all the types of workloads it's going to require and the required item types. Now it's going to create a warehouse and a lakehouse, and it will then create a set of steps. Now I could change this. I could say I don't want this anymore. I could get rid of this completely. I could say I want a new type completely. I could add my own types of items into this. I could just delete this entirely. But the point is, it's going through and guiding me for what I might want to do. Bronze data, silver data, gold data. I'm just going to delete this because I don't want it. But realize they're there to help you. So it's super powerful. But what that means is the medallion architecture is all about. So bronze would be that raw, unprocessed, uncompressed data from the source. I'm just extracting it and I want to load it in somewhere. Well, that would be the Lakehouse. Silver might be, okay, I start to match and merge and do a little bit of cleansing. Well, that might be my silver medallion data. And that, again, would still be in my Lakehouse. And then the highly refined, the aggregated data that makes up my gold, that I would put in my warehouse. So don't think of it as an either or. Think of it about what is the right storage based on the engine I want to use for the stages of life my data goes through. And again, those task flows can help you get that right. Now, so far, all I've covered is the storage side. And again, there's KQL capabilities to interact. There's other things I can store. But I've really just talked about Lakehouse and warehouse. And of course, the point then is once I have all of this, I want to do different types of activity on top of these based on my personas. Data engineers, data scientists. And so I want to pivot just a little bit to start, okay, so a data engineer. So remember, a data engineer, and let's just change our view for a second. So remember, we have views in here based on our personas. So we took to a data warehouse, but I'm going to change it now to data engineering. Now, straight away, it talks about, well, for data engineering, okay, there's lake houses, notebooks, environments, Spark jobs, data pipelines, import a notebook. It's guiding me through some of the key things. There's recommendations. Show me what I'm doing here. Now, remember, pre-Fabric, I'd probably be using Azure Synapses Spark. I would have used ADLSGen2 accounts. I'd have gone through various types of hops to read the data. And my whole goal as a data engineer, commonly, is I'm working on a massive amount of data, a massive amount of processing. Compared to a scientist, it might be considered more basic types of action. I'm preparing the data that everyone else in the organization can then consume, do more advanced analytics on. I'm filtering, I'm cleaning, I'm transformation. I'm doing this at massive scale for different types of workloads. Now, obviously, Data Factory is one of the tools that a data engineer might be using to get the data in there. But then I also obviously have notebooks and leveraging Spark to do many different types of things. Now, this is their own engine. And when I think of data engine, there's really two key artifacts that it showed there. One of them is obviously the Lakehouse. The other is the notebook. Now, what's crazy about this, so we've got notebooks up here already, is I'm not provisioning any type of compute when I want to use this. At the workspace level, there's a starter Spark pool just gets created for us. So if I was to go and look at my workspace, look at my workspace settings, remember we had that data engineering science and we had our Spark settings. Now what it is doing by default is it's created this starter pool. It's a memory optimized, medium size, 1 to 2 nodes. So what's nice here is it has single node support. That's one of the features we have available to us. Now I could create my own pool. I could create additional pools and customize it. I could edit the settings of my particular pool if I wanted to as well. But this is just here from us. And what's happening is there is just a warm pool that Microsoft maintains of those size nodes, which means they're available crazy fast. Now you also saw there's the idea of environments. Environments would let me have the ability for different notebooks could run on different pools with different configurations. So there's a whole set of things I can do, but the philosophy is keep it as simple as possible until you want to go deep. And if you want to go deep, you can go really deep. So you can customize a lot of the different things. But from right here, let's just say I'm looking at my Lakehouse, for example. And if I open a notebook, I'm going to create a new notebook. So it's creating that. Well, let's just do something. 1 plus 1. Super complicated. And we'll run it. 1 little second, 2 little second, 3 little second, 4 little second. It's counting for me as well. But what's going to happen is really quickly, I'm going to get my response. So 2. That was not minutes waiting for it to spin up some cluster of Spark. It just went and grabbed from the warm pool a unit of compute that it needed to execute that query. And remember, I can still do all of the other cool things. I could still grab some data and drag it over. And now it's created the Spark query for me. I'm going to change that limit to 10. And I can run that. So it's creating the PySpark, Python. I can do other things in here. I can write other things. But it's so simple to go and leverage this. And I could obviously mix in, I could do other types of actions, whatever I wanted, whatever I'm used to doing. It's just available super, super fast to me. Now, one of the other settings you may have noticed in that workspace, let me go back to it again, was this high concurrency that I have got turned on. So what is high concurrency all about? So we know, okay, serverless compute, it's spinning it up. It's one of those engine types. It's one of those types of consumption that it would go against that pool we have in the capacity that's assigned to the workspace that's running this particular notebook. And then we have that high concurrency thing. Think again about what's happening. So if I think of the load and when I'm running that particular notebook and it's performing some action, it's provisioning at the time I execute it from that warm pool. It's grabbing a unit of actual compute to run that thing for me. So I'm running a particular notebook. So I'm running notebook 1. If I run a second notebook, it would go and grab another unit, another VM, to run it. And then I run a third notebook, a fourth notebook, a fifth notebook, etc., etc. And each of those have a certain amount of memory and CPU. And it's probably a lot wasted. I'm just running 1 + 1. Or I was running that very basic little compute. And remember, my Fabric capacity is at a certain level. So if I'm running 5, 6, 7 things concurrently, and they're each using this unit that's consuming a certain portion of the capacity, I'm wasting a lot. And these are really idle. They're not doing very much. I'm not using much memory from it. Its actual utilization is like here. Ton of waste. So if I turn on high concurrency, what high concurrency says is, well, look, this is silly. Instead of that, what we'll actually do is 2, 3, 4, 5, running that same unit. So now my consumption would be much higher within that particular unit of compute. So I'm being way more efficient with the actual resources that it's assigning to run that. Now, it still has to worry about running out of memory. So the maximum number of notebooks in a single session is 5. And I cannot share a session between users. So it has to be for a single user because there's security boundary considerations of that. But this is what the high concurrency does. It lets me run up to 5 notebooks in a session. So I can turn that on. It will be more efficient with the actual usage and avoid trying to waste the capacity I have there. And so if I think about data engineering, yes, the data factory, the notebooks, the Lakehouse, they're just huge capabilities that I'm going to be leveraging across all of that. Then you can think data scientists. And I always think of data scientists as it's taking what the data engineers do. So if we pivot our view to a data science, it's really adding the idea of machine learning models and experiments. They're still using lakehouses, they're using notebooks, they're using environments, but they're adding these models and experiments. They're going to take that clean, prepared data from the data engineers and run their own, potentially more advanced workloads on it that's more about predictive analysis. They work in the same place. So the data scientists, the engineers, they're using the same tools. I'm using a notebook to train a model. I just have these additional capabilities. I'm exploring the data. I'm training the models. I'm applying the models. I have this whole exploratory data analysis, EDA. There's low-code UI experiences to create my models. There's a data wrangler, which not only cleans my data, it gives me the code on how it cleaned it. So yes, it will go and help clean the data, but then I can go and rerun that through the code it generates. So it's really this end-to-end experience. They talk about 5 by 5. 5 seconds to get started, 5 minutes to get meaningful results. And we'll see that data wrangler in the notebook. So if I jump back over, do I have my notebook still around? Or did I get rid of it? Let's see. Is there a notebook? Oh, there it is, my notebook. So one of the things you see here is the data wrangler. Now, I would have to go and actually set some things up to start using the data wrangler, which I have not done. So notice it's finding the data frames. I can do a custom sample. But the whole point of this is it provides this immersive interface for all of that exploratory data analysis. It gives me a nice grid-like data display, but also this dynamic summary of the statistics. There's built-in visualizations. It does that data cleaning, that data. Let's just pick. So we just get this sample view. So I can start to see the operations. It's giving me this great insight into everything that's going on. Drop duplicate roles. apply. So it's showing me what it would do. It's showing me the code that it would be doing around there. So it really is a super powerful set of capabilities. It's doing that code generation as well. So it's really simplifying all of the data preparation, making my data workflows more efficient. Now, one thing to consider about this, this is using this fairly generalized capacity. And what I mean by that is there's no special GPU accelerations at time of recording available to me. So if I was doing video or image processing as part of that science, it may struggle. Now, if it's standard text, if it's tabular data, and the end game is business insights, that's going to be absolutely fine. But just bear in mind that could potentially be a challenge if I am working with images and video, because it's using this more generalized set of serverless compute for those experiences. The final thing I wanted to talk about was Power BI. Now remember, Power BI is all about the idea that I want to create these super nice semantic models. And with those semantic models, I get the data into a format that's easily consumable by the business users. I can abstract away complex data structures. I can put it into an understandable format that the business users can then go and create and perform analysis on. I can rename tables, rename columns, create relationships, apply logic. I can do a whole bunch of cool things. I can create layouts and even automatically create sort of mobile app layouts. It's a really powerful capability. And now I have all these workloads that are talking to my OneLake. One of the things I have to do is the semantic models are using data from some source. And I have this analysis services. Now, in the past, we have different options on how I could actually get data. I could do an import mode. So I could think about, okay, import mode, that's bringing in the data into memory, but I have to store it locally. I have to go and then refresh the data when I want to publish it. So there's a challenge with that. If I was going from SQL Server, well, in SQL Server, we had a direct query mode. Well, it had to do a translation. So a performance hit. Because what it was having to do here is the visuals I'm doing in here talk DAX. And then it has to convert that to SQL. So there's some performance hit and lag introduced. It's constantly going and talking to it. With Microsoft Fabric, with the OneLake and Power BI, we now have this new direct lake mode. We'll do this in a different fancy color. Because now it's just talking to it directly. There's no translation. It's just working directly with the data in that Delta Parquet format. Remember that V-ordering we talked about? It gets a massive, massive performance boost. You can compare it, because obviously I could still create a semantic model based on direct query mode and use the SQL endpoint to my Lakehouse, for example. There's a crazy difference in the performance between those things. Now, that direct lake works on the structured Delta Parquet content in the Lakehouse only, obviously, not unstructured content. Now, I can't just toggle that on. It's at the foundation of the semantic model, so I would have to set that when I create the semantic model. Now, there's still an upper limits number of rows it brings in, but there's no translation with any of that direct query. And this is going to be your preferred approach. There's really not a reason you wouldn't use this. I mean, I guess technically, if I already had a semantic model using the SQL endpoint, and I don't want to rebuild it, it's very complicated, then sure, I'd probably stick with that direct query mode. But if I'm creating a new one, you are going to want to just leverage the direct lake mode. So if I was looking at my Lakehouse, I could actually just go and create a new semantic model. And let's just select those two. Model 1, can't type very well. And then once you're in the semantic model, remember, you would go and create those relationships, refine things that you then want to make available to those business users. And remember, it's leveraging that shortcut data as well that I put as part of the holidays. And note, when I look at the tables and look at the advanced, I'm in direct lake mode. So that's my dimension customer. And this is my shortcut to my warehouse, direct lake. So I'm going to get that amazing performance. Then I would go and do all of the regular things I would do in Power BI that I typically have. Now, another consideration would be, remember, one of the things I could do in SQL is row level security. If I'm doing row level security, I can't do direct lake because I need the SQL to be enforcing those row level permissions. So I'd have to use a direct query mode. I'd have to go via the SQL endpoint. Now I could do Power BI row level. That's absolutely fine. I can do that on the semantic model within Power BI. And it will actually, even if I'm using direct lake, check into the SQL endpoint periodically to make sure you've not turned on row level security, because then it would have to go via the SQL endpoint to have that enforced. But that would, I guess, be one reason why I wouldn't use direct lake mode. So if you can try and avoid it, don't do the row level in SQL, bring that up a level. Another thing I can do once I create my semantic models is you can I'm storing it in my workspace. So with OneLake integration, once I've got my semantic model, remember I could be importing data from CSV, I could have calculated columns in memory, I can publish it to the Fabric workspace, and then the next time I refresh it, it gets populated into the OneLake, which can then be consumed by the other engine. So I could now have a notebook using Spark to consume what I've created in my semantic model. Now, it's not going to include runtime aggregation. So if I had a measure, that wouldn't be included in what's published because that's a runtime. It's not going to show me relationships between the tables, but any of the calculated columns or tables, that would be available to me. If I wanted that data, I'd have to implement that somewhere else. But I can actually take those semantic models and as you can create it as an item within my OneLake, so I could then consume it as it refreshed from Spark and other types of engine. But that direct lake, if you take away nothing else, the direct lake is just massive in terms of the performance for Power BI. Now, one thing you obviously have to talk about in this day and age is AI. And yes, there's multiple dimensions when you think about artificial intelligence. Absolutely, there are copilots for everything. There's copilots to help me create SQL, to create my Spark, to organize my models. That's almost like a table space now. To create my notebook content, it's there. There's something they've also talked about. I can't demo it, I don't have access to it, but there's also going to be something called AI skills. So this will be a type of item that you can create that will let the consumer of what you have here in the data use natural language to interact and get help. So I think that's going to be a really nice capability there. One final thing that's not a feature of Fabric, but it's something Fabric's going to make way more easy thanks to the OneLake, is think what this has become. Now, all of the data these engines are writing are stored and linked from this single namespace. I can also include data that's in AWS, GCP, other things. I can mirror data from Cosmos DB, Azure SQL, Snowflake, and they're all treated the same. Once they're in here, I can consume them. So now there's this single namespace that's all of the data in my entire organization. Well, what would be really nice to do here is Purview. So Purview obviously works with OneLake. So and it works with the shortcuts, it works with the mirroring. And now all of those different sources come together because Purview just has to work with OneLake. OneLake is doing a lot of the work with regards to the data, with the shortcuts, with the mirroring. So when I think about my data governance requirements on discovering my data, the classifying, the protection, Purview can now work on the OneLake and get that single view and make it far easier to discover and apply those protections for the organization. If you're curious about where things are going, there is a roadmap. So if we go and look at the roadmap, there's a what's new and planned, and it breaks it down into the different components. So if I looked at OneLake, for example, it talks about what it's working on. So shortcuts to on-premises data. That's obviously there. Data access roles, OneLake security model, and then things that it's actually shipped already. So I can go and look at the different sets of capabilities to see, well, where is this thing I'm interested in? Where is this actually happening? So obviously private link at a tenant level, they've done that. Managed VNet support, yeah, we saw that already. But you could go and look. So there it talks about private link at a workspace level, which I think will be super interesting. Okay, Q4 2024. So I can go and look at what's planned, what's coming, and even see what's been shipped recently. So I think this very transparent view of what's coming and what's new, I think that's going to be really powerful for people. So that was it. I mean, that was the stuff I really wanted to cover and talk about as part of this talk. I know I've talked about a lot. I always do. I apologize. But I hope it gives you some idea of what Fabric is. Because I know for me personally, I was like, oh, is it just a suite? And it's really not. Again, take away one thing from this, and it's this OneLake becomes a point for your entire tenant that all of the different engines can now talk to and consume. So there's no more silos, there's no more painful transformations between things. All the engines have been updated to work with this open Delta Parquet format. And then if you bundle in and couple that with the shortcuts, bringing data in from other places, and we saw that's expanding, couple that with mirroring for structured sources, couple that with the Iceburg metadata support and the X-table conversion to another way. If I actually want to read and write Snowflake, I would use the Iceburg metadata as opposed to, hey, I just want to be able to consume it for analysis. The fact that that OneLake is based on the standard ADLSGen2 API, it means it's just this open interoperability, it's a complicated word on a Sunday morning, for anything. It's not just for Fabric. That OneLake becomes a place that any application and workload can work with because it's just that easily interoperable API that things are used to already. It's got this really powerful serverless compute that I get a virtual bucket based on the amount I've provisioned, but it lets me do this massive bursting, and then I pay it back over the next 24 hours. So I don't have to heavily overbuy because I have some peaks of the things I need to do. We still have all of the core experiences we're used to for data engineering, data science, the warehousing, the analytics side, sprinkling our copilots, the AI skills, that Purview that now works with the OneLake. It really gives us as an organization this amazingly powerful. And I think some of the capabilities, I think the workspace private link will be huge for a lot of companies. So I think that's a very welcome thing that's coming as well. But it's going to kill this pain off. These silos of data, these transformations, because this engine has to talk this, it goes away when we think of this open standard that all the engines have been updated to talk to. So that was it. I really hope that was useful. As always, till next video, take care.